Okay, the name of this section 9.1 is Mathematical Patterns, and I showed a couple of patterns on the smartboard. This one here is really cool. It is wavy, and if I guess you could go to the you could look these up on the internet, and I found them. One of these was on Wikipedia, a GIF of it forming into the star, and then this one here I found on Wikipedia too, and like brought it in and imported it, and it's like this wavy thing that comes at you. So that's the name of the snowflake, but that's just kind of a fun mathematical pattern. What we're going to work with in this section is sequences. So a sequence is a list of numbers, and there's notation for that, and the notation goes something like this. A1 is the first term, and A2 is the second term, and A3 is the third term, and then AN is the term out in the future somewhere, so we call that the nth term, and then the term that's after it would be one term more, so we call that the next term, and then we're going to call this one the previous term, the one that's before. So if we go 5, 10, 15, 20, etc., somewhere out in the future would be like 75, 80, and the one before it would be 70. So then this would be like the first term, second term, third term, the nth term, n plus 1, n minus 1. Okay, so it's just a list of numbers. And there's different kinds of sequences. You can do sequences by adding, subtracting, multiplying, dividing, or just a list of numbers in a pattern. So we're supposed to write out the first 5 terms of this sequence with a formula. This is called the explicit formula. With the explicit formula, you can jump to any term that you want to. So you can make n 100, you could go to the 100th term, you could go to the 8th term, you could do it any term you want to. So A1 is the first term. So that means n is 1. So it's going to be 1 squared minus 10, which is equal to 9, negative 9. Then A2 would be the second term. Now 2 squared minus 10 will be 4 minus 10, which is negative 6. And then the next term, A3, would be 3 squared minus 10. So I'm just putting 3 into the formula. So it would be 9 minus 1 is negative 1. A4 would be the fourth term, would be 4 squared, which is 16 minus 10, which would be 6. And then A5 would be the fifth. 5 squared minus 10 would be 25 minus 10, which is 15. So if you line them up like a sequence, it would be, negative 9, comma, negative 6, comma, negative 1, comma, 6, comma, 15, dot, 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 forever. All right, so that's this formula generates the sequence. Okay, this is if you go to this YouTube video, you can watch a ball bounce, but basically you have a ball and it goes down and it bounces and does this and it does this, and we want to know how high it returns on its 5th bounce. So we do 100 is the first centimeters, is the first bounce, and it comes back 80%. How high is it after its 5th bounce? So we drop a ball, right, and it goes bouncy, bouncy, bouncy ball, etc., etc. So it's 100 centimeters the first time, and then it's 80% of that. So that would be 80 centimeters. And then 80% of that, so I'm multiplying by 0.8, would be 64 centimeters. Now I'm going to use a calculator. So 64 centimeters times by 0.8 would be 51.2 centimeters. So 51.2 centimeters. And then the next one would be times 0.8. Be 40.96 centimeters, 40.96 centimeters. And then we're going to go back 80% of that, so multiply by 0.8 again, and you get 32.768 centimeters. So that's the answer, because that would be after 1 bounce, 2 bounces, 3 bounces, 4 bounces. After 5 bounces, that's how high it would come back up. So this is a sequence too. This sequence right here, so there's different kinds of sequences. This one's done by adding 5 every time. This one is done by a formula. We have a formula that we can do. This one's done by multiplying by the same thing every time, or dividing because it's getting smaller. Now this example here, we're going to write the explicit and recursive formulas for this. So for the recursive formula, and we got the explicit formula here. So the explicit formula is where you can jump anywhere through the whole thing. So the explicit formula is right this one, or you can jump anywhere that you want to go. So it has a formula for n. Okay, so what we're going to do here is for the recursive formula, you always have to say what the first term is. So we say A1 is equal to 2. You have to say what the first term is. You have to get it going. So that it's like putting a P at the top of a hill with snow, and like it rolls down the hill and makes a big snowball. You got to start with something. So then AN would be, what's going on here? Well, we're multiplying by a number each time. Oh, it doesn't take too long to figure out we're multiplying by 3. So it's going to be 3 times the previous term. Well, the previous term we've identified as AN minus 1. So that's the previous term. So we just do 3 times the previous term, AN minus 1. Now the explicit formula, you're multiplying by 3 every time. So it's going to be AN, it's just a formula. So it's going to be 3 or 2. You have to have a starting point, and then times 3. Well, it's a bunch of 3's being multiplied out, so it's going to be 3 to some power. Well, if I put 1 in here, that'll be 3 times 2 is 6. So I really need it to not be times 3 on the first term. So I'm going to subtract 1 to move it back 1 space. So let's make sure this formula works. A to the 4 would be the fourth term, so it would be 2 times 3 to the 4 minus 1, which is 3. So that would be 2 to the 3 to the third. Well, that'd be 2 times 27, which is the 54, the fourth term. So that works. That formula works. And the n minus 1 is a helpful thing here. Now over here, does this formula work? Well, A2 would be 3 times, now put the 2 there, A1. Well, A1 is 2, so it'd be 3 times 2, which is 6. Then A3 would be 3 times, now put the 3 right there, it'd be A3 minus 1 is 2. So that would be this previous one, which would be 3 times 6, which is 18. And then A4 would be 3 times, put the 4 in here, that would be 4 minus 1 is 3. So it would be 3 times A3, which would be A3 is 18, so it's 3 times 18, which is 54. So that's making the formula. Okay, so there it is. Explicit, you have to ka-chunk your way through and just start with the first one and keep multiplying. Here you can jump anywhere you want to. Like if you wanted A50, right, it would be 2 times 3 to the 49th power, and that would be the 50th term, whatever that huge number is. Okay, so you can jump anywhere you want to in the sequence. All right, and there's the assignment on this page.